Students, welcome back to my channel. I know it's been long since I uploaded a video regarding this topic about matrices, about linear and algebra that is. But now it's time to take our series to the next level. And I had not forgotten my transfer password. It was just that I was feeling a bit lazy to get videos. Anyway, I think as far as I remember, I was done with matrices. You know, the concept at least for your like he was just for just as much as our syllabus allows us to. Today, staying in that limit, and we are talking about what determinants. So, what are determinants? I can go into depths and explain why things are happening the way they are, but it's just that our syllabus is being a bottleneck here. I just won't be able to go into as much depth as I want to. For your syllabus, you just remember that determinants are nothing more than a scalar value. Let's say you have a matrix, a two-dimensional matrix with elements A, B, C, and D. So this means the determinant of this matrix, which is written down as like this: A in between two parallel lines, or it's also written like this: dt of A. This would be written as the elements of this matrix instead of two parallel parts, instead of two half enclosed, like a box which is partially enclosed. Then I write it down like this. Now the value of this determinant would be A times D minus B times C, and you probably won't have a single idea about like what the hell is going on here, what am I talking about, what is determinant, and blah blah blah. The thing is, these topics have all of them have been derived from linear algebra, but if I get the depth of this topic in algebra, I try to help you visualize what is going on, that would be just way too hectic. Just remember that if any of you guys are interested into doing the college majors in mathematics, you'll probably, not probably, you'll definitely get to know about like why things are happening the way they do. Okay, this was the formula for a 2 by 2 matrix. Now let's say a 45 matrix plus a 3 by 4 matrix. Let's say the matrix A, the elements A, B, C, D, E, F, close the top E, F, and G, H, I. In this case, the determinant of this matrix would again be written like this: A, B, C, D, E, F, G, H, I. And in this case, the value of this determinant would be A times the value of the determinant with the elements that are not part of the row or the column that A is part of. So what I'm talking about, first of all, let me write it down like this. First of all, I'll have to write down the elements of the first row and the size of the first or the third element would be positive, and the second element would be negative. And then with a, I'm going to multiply the elements in the form of a determinant who are not a part of like the row in the column or element A is part of. So which rows and column, which row and column A is part of? A is part of this row and this column. So when you exclude these two, this row and this column, what you are left with is E, F, H, I. So you can find a determinant with that. This would give us a 2 cross 2 determinant, and we already know how to find out the value of this determinant. We will do the same with D as well. D is part of first row and the second column, so we will ignore these two. And the elements we are going to be left with B, C, H, and I. We are going to form determinant with that B, C, H, and I. And we are going to be doing the same with element G as well. G is part of the first row again, and this time it's part of third column. First column is the part of the third column. So we are going to be including these two divisions, the first row and third column, and what we are left with is B, C, E, F. We are going to be forming a determinant with them with that. And this is the value of this 3 by 3 matrix. Now you can simplify this a little bit. You can write it as A times the value of this determinant, which will be the product, as I told you guys in the earlier section of this video, the product of the elements of the main diagonal minus the product of the element of the secondary diagonal. So it will be A times EI minus HF minus D times BI minus CH plus G times BF, not the BF we are thinking about, minus CE. Okay? So this is the formula of a 3 by 3 determinant. I know you guys might be in a lot of, you guys might be stuck in an ocean of doubts, like what the hell is going on here. The thing is that matrices are linear transformations, and what does that basically mean is, like, a matrix tells you how much a 3D space has been expanded or squished linearly. And the reason why I would still don't get anything what I'm talking about is because I'll need animations and stuff to properly explain you guys what is going on. And I mean, obviously I don't have that kind of resources available with me, and neither does the syllabus allow me to explore topics into this much depth. So for just high school level, you just keep in mind that this is how things happen. Okay. So with that said, I'm going to end today's class. Wait for the next one, and until then, keep learning.